Welcome to this session. My name is Ajit Surinshi. I'm from the Electronics Department, Electronics and Telecommunication Department from Walchand Institute of Technology, Solapur. And today's topic for this session is bipolar junction transistor. Let's move to the next slide. What is the outcome of this bipolar junction transistor is, at the end of the session, student will able to learn working and characteristics of the bipolar junction transistor. And the content of this session is the prerequisite. So whatever the knowledge you required before proceeding in this. What is a transistor, construction of and types of the BGTs, current transportation in the BGTs, different configurations of the BGTs, biasing of a BGT, comparison of this CE.CB CC configuration, and application of the BGT as a switch. Prerequisite. So before proceed further into this session, you should have a knowledge of semiconductors, a knowledge of a PN junction diode, and knowledge of an applying a Kirchhoff's voltage law, Kirchhoff's current law, and Kirchhoff's voltage law. So what is meant by the transistors? So brief history of the transistor is started from the vacuum technology or vacuum diode technology, vacuum diode and vacuum tetrode, vacuum pentode. So in that, a current or electron is controlled by the heating element, filaments, and vacuum diode and vacuum tetrode and vacuum, these devices requires a large amount of the power as compared to the semiconductor technology. With the advance in the semiconductor technology, so first transistor was successfully demonstrated in 1947 by in the Bell laboratory by Shockley and other fellow members. So this is about the transistors and what is meant by the transistor and how it is defined. So transistor is basically the combination of the two resistors, transconductance, and transfer of a resistance from low value to high value. So because of this transistor, it gets the property of an application of this amplification of the signal from low amplitude to a high amplitude. So different types of the transistors are bipolar junction transistors, field effect transistors. In a field effect transistor, there are two types: junction field effect transistors and metal oxide field effect transistors. So bipolar junction transistors are the current control by controlling the current in the controlling electrode, you can control the electron flow, and in the field effect transistor, by controlling the voltage, you can control the flow of electron. So why it is called as a bipolar junction transistor, that we'll learn in the next slide. So that is it. This is a construction and the structure of the transistor, semiconductor transistor. So transistors are of two types: PNP transistors and NPN transistors. So in the PNP transistor, N-type layer is in between the P2 to P types of the semiconductors. So, and in NPN transistors, a P-type base is in between the two N-types semiconductors. So P-type in PNP transistor, first layer for that is P is called as emitter, center one is called as a base region, and the third one is called as the collector region. Okay, so in the for PNP transistor, P-type, first region P-types act as an emitter. It will emit the large number of electrons. And in the NPN transistor, and first layer or first region act as a emitter, which will emit the large number of electrons. So in this emitter region is highly doped as compared to the collector. So collector junction is a moderately doped as compared to the emitter, and base junction is a lightly doped. And also you can observe one thing here, that is a dimension of the collector is somewhat more as compared to the emitter, and the dimension of the base is somewhat less. So that makes it an ideal device, which makes the emitter current is approximately equal to the collector current. And here there is the symbols of the PNP transistors and NPN transistors. So in the PNP transistor, if you note the symbols of PNP transistor, so that direction of the current is flowing into the device, that is, and in the NPN transistor, direction of the current flowing out to the device. So you may note that direction. And among the PNP transistor and NPN transistor, NPN transistor is widely used. Why? Think about it. Answer to this is because in NPN transistor, the current is because of the electron, and electron have a higher mobility than holes. Okay? And this is called as a bipolar junction transistor because current flows due to the electron and also the holes. Okay? This next slide, that is current transportation in the BJTs. In the current transportation in BJT, as I told you, the NPN is most commonly used for application as a transistors. And here N type of region act as an emitter. So emitter region, if you see in the emitter and the base region, it is emitter junction is a forward bias by the battery of VBE. Collector junction is a reverse bias by the battery of VCB. So due to the forward bias, and that N++ symbol denotes that it is a highly doped as compared to the collector and from the base. So this is highly doped, it will emits the large number of electron because emitter junction is a forward biased. And as P-type, base type is a lightly doped, a few of the electron will combine to form a base current, and most of the electron will continue its transportation from the electron to a collector region without recombining, most of them without recombining into the base electron. And you can see this, the current, base current constituted of only two parts, that is due to recombination, and some of the holes, as it is a very lightly doped, will manage to cross in the electron region. So at large, you can conclude that the current in the NPN transistor is due to the electrons. If you apply the KCL, considering the transistor, NPN transistor here as a junction, you can have a emitter current is equal to collector current plus base current. These are the different configuration of the BJTs: common base, common emitter, common collector. So in the common base configuration, base is common between input and output. In common collector configuration, collector is a common between input and output. And this in common emitter configuration, emitter is common between input and output. So these are the current gain of BJT for different configuration. For CB configuration, alpha is equal to IC divided by I. So in the CE configuration, collector current is output current and emitter current is input current. So you can define the current gain as output current to input current. So IC divided by I for CB configuration, and beta for that is current gain for the CE configuration is IC divided by IB. So here IC divided by IB. And for CC configuration, gamma is equal to I divided by I. Also emitter current is equal to IC plus IB. And hence from this equation we can derive alpha is equal to beta divided by 1 plus beta, and beta is equal to alpha divided by 1 minus alpha. So this is the experimental setup for determining the characteristics of the CE configuration. CE configuration is most widely used as compared to the CB and CC configuration. Here, to determine the voltage, input voltage VB voltmeter is there. To determine the input current, IB is there. IB is a very small source, so it is in the microampere. And to determine the output voltage, here voltmeter VC is the voltmeter. And to determine the output current, here current is in the milliampere. So milliampere is used here. So these are the input and output characteristics. So this is output characteristics of a transistor, and this is for CE configuration. and this is the input characteristics of the CE configuration. In the output characteristics, you can see there is the region is divided in two parts. That is a saturation region, and this is a cutoff region, and this is what it is called as a active region. So biasing of a BJT is necessary because to operate the transistor in the active region. Because in the saturation region, current flows, but voltage across output voltage very small. It is around the 0.2 volt for a CE configuration. So saturation region, active region for active. So this kind of this active region biasing here. So in this region, transistor or CE configuration is act as a amplifier. And in the cutoff region, current it is near to the zero, or current which is equal to the reverse saturation current in the cutoff region. So for amplifier, it is biased in the active region, and for the saturation region, it is act as a cutoff, and it is in the biased in the saturation and cutoff region. So different comparison of the CE.CB configuration. Here input resistance and low, high. Output resistance is high, low. And the current gain is unity, less than unity, high. Voltage gain is medium, high, less than unity, and phase shift is 0, 180 degree, 0. So application, it is used for a high frequency application, for audio frequency application, and it is for the CC configuration for impedance matching. And this is the application which used as a transistor, as a switch. So acknowledgement, these are the acknowledgement for the BJTs, for electronics devices. And thank you very much.